picture.
As a picture?
Yeah, now it's a video.
Great. So my name is Asher Barak. Don't try to pronounce it. Break your teeth. I'm from Israel. I recently translated a very important book called Code Complete. Has anyone here heard of the book? Nice. Have anyone read it? Okay. Those of you who haven't read it, it's a good time. And those of you who haven't heard of it, you heard of it. Okay, so now you have no excuse, go read it. We'll talk a bit about developing in general. The talk has a little code, but it's not related to any specific programming language. It's good for everyone who does coding. Let's start. Does anyone know this guy? No? I'll give you a hint. He died not very long ago. No? Okay. And he was one of the leaders of a cognitive psychology field. Anyone?
Seems the author of Flow. The author of Flow.
Flow?
Yeah.
I'm not familiar with that.
Okay.
Okay, his name is George Miller. Okay. Does anyone know what George Miller's contribution to our world is? No? Okay. Do you know the number 7? And something you do know. How does that relate to anything? Okay, let's try this. 7 plus minus 2. Does that say anything to anyone? Yeah, go ahead.
It's about person can retain, not about.
Great. This is this is the cache of our brain. Okay, this is how many items we can keep in our brain at once. This is very. Now that I'm saying it, you all know it, right? We can remember about 7 things. Some people can remember a bit more. Some people remember a bit less. So there are many experiments showing this. You tell people the names of animals, for instance, and ask them to remember that, and they can do quite well till around 7. And when it gets up from there, people just are hard to remember. It's sometimes referred to as the magical number. Okay. Do you know this guy? Anyone? Yeah, you know who this is? Yeah, this is Mr. Heisenberg. It's not him, it looks a bit like him. Yeah? Okay, so who is this? Dijkstra, that's very nice. No one ever knew, in the past, no one ever knew this is Dijkstra. Can someone tell me what Dijkstra's contribution to our field is?
Concurrency problems. He solved a lot of concurrency problems.
Right, that's right. Anything else? Anyone? Okay, the graph, okay, because that's the algorithm named for him, the shortest route between 2 points on a graph. And he also wrote a very important piece, go-to statements considered harmful. Does anyone know that? Well, for programmers my age, you might remember that we used to use go-tos a lot. And at certain point, someone came along and said, well, guys, that's not good. You're going to get spaghetti code. Don't do that. So Dijkstra is the one. I think he had partners on that article, but he published an article, go-to statements considered harmful. And we all know nowadays we have better solutions, and they are harmful indeed. So this is Dijkstra. Dijkstra said that software is too complex to fit in our brain, which is something is daily knowledge for us. The number one goal of software development, and this is mainly the point, I think this is the point of the book, and this is the point of what I would try to demonstrate for you tonight, is that managing complexity is the first priority when building programs. And we'll go through some best practices and some stuff we do daily and understand how this relates to managing complexity. And once we understand how everything is related to managing complexity, we can tackle new situations and ask ourselves the core question: does this help me manage complexity, or does it not help me manage complexity? Okay, when I say manage complexity, I refer to what George Miller found, we don't want to be having too many balls in the air at once. Okay, if we can only keep in our scope 7 things, we want the 7 things to be 7 things that count. Okay, and all the other things, we have to find a way to push them aside and not to handle them at the same time. Let's see. Who's that guy?
Socrates?
No? Okay, you're close. Okay, this is an old guy. He's a Greek philosopher.
Greek.
Oh. And this is Aristotle. Okay, so Aristotle taught us something very important. He taught us the distinction between things that are essential and things that are accidental. The essential things are the qualities or the properties that make something what it is. For instance, if we have 2 cars here, a car has some essential properties such as it has wheels and it transports people, and until very recently it had a driver. Okay? And a car also has some accidental properties that can vary between cars. A car can have a V8 engine or have a sewing machine engine. A car could be nice and bright and shiny, and a car could be rusty and old. But nevertheless, they're both cars because they share the essentials of a car. Okay? Referring to software complexity, we have many issues that make software building a complex thing. Okay, so if we try to have a look at the list, computers speak binary language as we speak higher level languages. So this is a problem. Computers are batch machines. Okay, computers are when we write code, we have a large gap between the code which works fine on my machine and the code that runs on the machine of the client after the deployment phase, which is not running properly. And computers are not good with concurrency. You know that each processor only does one thing at a time. Yeah, you're aware of that. But we have some abstractions over it. We'll discuss it in a minute. Computer has physical limitations. They can only do so much. And computer software models a complex world. Okay, we live in a complex world. No, the things we develop are complex. Okay, so if we try and look at this list and think of the achievements we've had over the years of programming, say the trade of programming is something that is maybe 50 years old if you count the punched cards. Anyone here likes history of computing? Because even I never saw the cards they used to punch. You know what I'm talking about? Yeah. So maybe 50 years. So over the years we've learned a few things. Like if computers speak binary languages, we don't have to speak binary language too. We can have abstractions over that. The third generation programming languages are almost readable for humans. So we've overcome this problem. Computer are batch machines. Okay, we've overcome this problem. We now have a inversion of control. Everyone is familiar with this term. I'll give 2 words. If in the past the computer would be like anyone wrote a console program for .NET, or Java also has a console program where the program runs and outputs stuff and then holds and asks you for an input. Yeah, like so. We've changed this model of programming. Now we have buttons on forms, yeah, or on screens of HTML screens, and we have functions that are getting invoked when the user presses the button. We call this inversion of control. Instead of the program being in control of it all of the time, the user is in control of what's happening in the program. So this, in a way, solves the batch problem because we now can be interactive. Of course, it requires parallelism, but we'll discuss this in a minute. We're getting better with the problem of deployment. Okay, we're doing processes and things that get us continuous deployment. We do better testing, and we're able to take our product to the customer more easily over time.
It stopped.
just like that, limited on time. Computers are not good with concurrency, but we now have abstractions of a concurrency. Most of us use, what do you use for that? Threading, of course. But there are new styles now. Anyone doing Node.js by chance? No? Check out Node, it's very interesting. Node has a different philosophy about that. Node doesn't have threads, but it tackles the issue in a different way. So let's say we've done quite a few steps in the way of dealing with concurrency. And physical limitations is also something I think we are with the Moore law. Everyone is familiar with that. Computers are getting stronger and stronger, and we now can cluster computers and cluster machines and build great huge data centers. So we're passing the limitations of physical limitations of computing, but there's something that will always be relevant to computer software development, and this is the complexity of the real world. Okay, so if we try to implement Aristotle's thinking, these all are accidental, but this is essential, and this is why we cannot wait. The tools are always evolving, and the mental model we use to program always evolves and allows us better access to better ways of thinking that make our non-essential, our accidental problems grow smaller and smaller. But always the complexity will still be our main problem, because some of the complexity is essential. Okay, it will never go away. So, what do we do? Okay, the main thing we should do is try and do one thing at a time. One thing might be too little, but no more than 7 things at a time. Okay, we should focus. This is a very annoying picture. Yeah. So we need to care about less. This is the main goal of our development. I frankly hope everyone knows where that is coming from. If you do not, please come to me at the end. Really? Okay. Not a great movie fan, right?
Nope, not really.
No. Okay. You know, there's some common ground. Like, if I would refer, we're all geeks, so I can refer, Game of Thrones. If I throw in a Game of Thrones reference, would someone look at me idly? No. Okay, so there's a fine line. It shifts. Okay, like my kids get home and they need. I have kids, yeah, and they need the new album of something, and I have no idea that something existed, so I know it's a different generation. So I'm trying to aim for some things that are common, or I think are common. Yeah. Okay, so we want to do as little as possible. Okay, we want to divide, and by that conquer. This was also a reference. We want to hide details. Okay, we want to have layers. We want to focus on the thing at hand and not worry about other things. Okay, and we want to reduce the noise. Okay, so everything that is not essential to the task at hand, we want to push it away. Okay, let's see how we do that. So the first thing is the language fundamentals. Okay, all programming languages provide us with tools that aim exactly for this management of complexity. I would go as far as saying that the whole thing that the languages do is help us in managing complexity. But let's see some of the examples. Of course, when we write, we start with what we call procedural code, which is lines of code that run one after the other. And what's our first tool after that?
Object-oriented.
Almost. It's the methods. Okay, we pack our code in methods. Now, if someone comes to you and asks you why do we use methods, sometimes the first answer that comes to mind is reuse. Okay, we need a method because we can, if we have the code packed into a method, we can use it again in some other place. And while this is a legitimate answer, and it is true that code reuse is enabled by methods, this is not the first reason to having method. The third reason to having methods is that it helps you manage the complexity. How does it help you manage the complexity? Instead of having a method with 50 lines of code with a remark for the first 5 lines that says initialize variables, and then for the next 10 lines you have a remark saying, I don't know, get customer current balance, you have functions. Initialize, get variables, and your code becomes more readable, the code for that procedure. And when you try to look at the code that does the getting the balance, you just go inside that code and you don't care about the rest of the function. Okay, you don't care about the rest of the function that calls it. So even if it's only used once and in one place, it's still good to have it as a method. This is also a way of documenting. Okay, if you have the method, instead of having a remark that says get initialize, get initial state, and then 10 lines of code, which you have to look through if you want to find some other part of the method, you can see that this is initializing because it's calling the function initialize, which replaces the remark too. And you can decide if you want to look at this moment or you don't want to look at it. So the next step in packing our code or in managing it would be classes. Okay. So this again, a class also enables us is a line where we can either look inside or look outside. Okay, I can look inside the class and I don't have to see what's going on in other places. So I can concentrate on the class and I have less balls in the air, less things I have to consider, if I have the class, what's next after the class? Okay, so now we got to another very important issue. Some languages have natural ways of packaging classes, such as Java packages. Anyone here writes Java? Okay, so in Java you can't write anything if it's not packaged in a package. Anyone here with the .NET? No one? Oh, so what's the .NET equivalent for that?
Namespaces.
It could be namespaces, though namespaces in .NET are not as strong as packages in Java. They are a bit more loose, okay? But I must tell you that it's very important to understand that if you understand that you need packages or you need something in a level that is above classes, you should not depend on the language for that. You can go and create your own module in your own way. For instance, you can use conventions for that. Okay, you can say that every class that belongs to a certain module starts with a prefix that relates it to the module. Okay, so now if you can talk about modules, you can start asking yourself what modules should be interacting with the other modules. Okay, so you once again create boundaries, like classes create boundaries between one another, so you can focus on the class. When you go to view your application in a higher level of abstraction, you would like to have modules and ask yourself, what is the border of the module? And when you think of the module, you can think of that module without thinking about the effects it has on other modules, okay? And that could be implemented with the tools of the language and can be implemented just by conventions without using existing tools in the language. Usually, after that, we have a conceptual level. I believe most of you are familiar with the concept of layers, which is usually not part of the language, okay? Maybe you could decide that for your architecture, the layer is reflected in an assembly, for instance, okay? For those of you who are working with assemblies. And it could be implemented in other ways, but usually when anyone here is familiar with the 3-layered architecture that was prominent a few years back? Okay, so this is an abstraction that does not reside in languages usually, but is very well enforced generally. So this can be also taken to other levels. You change? Does it ever happen that you add lines and you think that they're inside the condition and they're not part of the condition?
No, the linter will complain.
Sorry?
The linter will complain if they're.
Oh. Okay, so that's using tools. That's also very important. We'll get to that too. Okay, have a meeting conventions. Okay, how you do stuff. Have conventions for everything. Okay, that's short. So I got a really small segment of code which is in C# and also has a violation of what I just mentioned. You might be able to catch it. And I want to show you how much information is embedded in this small code sample that has nothing to do with what the code does, okay? And removes the mental load of trying to understand what the code does when I'm looking at the code, okay? I can focus on what the code does and not try to figure out the things I'm about to show you, okay? So I know this is a constant because this is the convention for C# and for all C languages for constant. They're all capitals separated with underscores. And it's nice to have the convention that everyone has, because if you have the convention that everyone has, a new developer doesn't have to learn a new convention, okay? So if you can afford that, why not? What is this? Anyone? Yeah, what's that? Row height.
Local variable.
It's either a local variable or a method input variable, right? What's this?
Class variable.
That's a class variable. Should be. Should be. Private. Should be. Okay. So I know all that without knowing anything. Okay. I know that, and let's see what this is.
Static.
This is a static property because this is the class. I haven't reached that yet, and this is a dynamic property, a non-static property, right? Okay, this is an instance. Okay, it's a variable, it's a local variable. I know it's an instance, okay, because it starts with a small letter. We know these are classes, okay. We know this class is an exception. How do I know that? Because it says exception. It's also being thrown. But this is the convention, right? You know, you name exception classes with the exception at the end, and these are interfaces, as they start with an I. Does anyone work here with an organization that doesn't start interfaces with an I? Yeah. Can you explain why? Because I don't remember. There's a philosophy there, right?
Because in our case, interfaces define behavior. Not,
There are mix-ins?
no,
No?
we do Java. So measurable, scalable.
Yeah, these are mix-ins.
No, they usually have able in the end, because they are like actions, like defining roles. It's,
Oh.
you have something that is called serializable or
You can defer that they are interfaces because they represent actions. Actionable. Actionable, right? Okay, so if you have a good reason and you think that's the right thing and you thought about it and this is your convention, God bless, be happy with it, happy coding. But if you want to go with something, interfaces are nice when they start with an I. We like them that way. This is our convention, it's good. Event args are things that inherit the class event args. They always end with event args. And I know all that without doing anything, without understanding what the code does. Does anyone see some inconsistency here? Yeah?
even that should be an interface.
Sorry?
Even that should be an interface.
No, event args is that's the C# way
Okay.
of creating the delegates. Have method parameters conventions. Okay. For instance, I know of an organization where they send first the parameters that are immutable, parameters that go in and don't change, then the parameters that might change, and then they have the out parameters. So that's a convention, and that's one less thing to think about. That's it. You look at the code, you know the order, you know what to expect, you know that this is going to come out of the function, and I'm going to use it later in the code. I can look for it. Use convention for placing resources. Your website might have a folder that is named src for resources, and img for images, and img/language, and for subdirectories for images for different languages. Whatever you do, it's fine. Just have the convention, okay? This makes it so that when you want to find a certain picture, you don't have to start searching and start guessing what's it named. Though if you have a convention for how to name pictures, it's very good. You can find it easily this way, but you should probably have both. Have documenting conventions, which can be we don't document. We have there are places when documentation is considered a smell. You know what the coding smell is? Coding smell is something that if you see it, it might be okay, but it usually indicates a problem. You have to look inside, okay? So if you do well and give your methods good names and pack your procedural code into methods that have good names, then why do you need the comment? Okay, if you have 20 lines of code that initialize the state of the customer, instead of having initialize customer state and 20 lines of code, have a function or a method initialize customer state and have it out. So in some places it's considered this way. Of course, if you have an external API or someone else in the organization or out of it is using your code, you probably have to document in some way. You have to document the outward-facing API of your code. So as long as you have a documenting convention, you're good. You'll know where to find stuff. Okay? Documenting convention goes outside the code. Okay, so like I'm working in a relatively small organization, and once in a while, I've been there for quite a few years. So once in a while, we sit and try to solve a problem for a customer, and we decide that we need some feature, and we start thinking about the way of designing that feature, and then somebody says, okay, we discussed this 2 years ago. And everybody says, oh yeah, we discussed this 2 years ago. Does it happen to you too, or is it just it's not a thing? Okay. So what I say in that case is go find the email, because there's always an email. Okay, when the meeting ends, someone sends an email that says we've discussed this and that. We're not going to do it, but here is what we thought. We thought of this and that, and we think we should do it this way, or we haven't reached a conclusion yet. But it's always documented by email. And this is a documenting convention, and I'm pleased with it. It's good. It does the job. You can use it to document both things that are happening and things that are suspended, and it's good for our organization. Our team size, our organization size is good for that. It's a convention. It's very good, and there's only one cost to that. You have to remember at the end of each conversation to say, please, you write an email, or write an email yourself. It has to be consistent. You have to have a convention about it. Okay, that's all. It's just juggling less stuff. That's all. Okay? This is almost trivial. Code layout conventions. Do you put your curly braces? Okay, let's ask you a question. I'm writing a method. Okay, that's for the C-influenced languages. If someone is working with something else, then it doesn't apply. I write, okay, method initialize state, okay, parentheses, and then I have curly braces. Okay, do I put them here in the same line and the closing one here? This is Java style. Or do I start the curly braces here? Does anyone have, okay, let's do a show of hands. who works in an organization where they start the parentheses in the same line with the curly braces with parentheses? Do you do Java? Java? I think Java does that. It's a Java thing, and I think JavaScript too. And who does? Who works in an organization that starts the curly braces? Who works in an organization where you can find either of those? That's very good. No, it's not so good. If you have a convention now, this might seem for someone who's less experienced, this might seem like a petty thing. Come on, okay, whatever. But it takes off mental stress. You have to deal with less stuff. Does anyone work here in an organization that an if block? If it's only one line, you don't do a block. Yeah? Whatever you can do, you can either do or not do. It's better if you have a convention for that. Feet. When I'm talking about an abstraction, what's the Spanish word for abstraction? Abstracción. Claro. Okay. I sometimes I wonder how someone can speak English and not speak Spanish, or vice versa. Though I can't understand the word Spanish, but it's also always the same. How do you say customer in Spanish?
Cliente.
Cliente. Sí, client. Claro. Invoice. No.
Factura.
¿Qué?
Factura.
Factura? Okay. So, an abstraction is something that helps us avoid the details. It's another tool for managing complexity. Now, when we speak of abstraction, sometimes you can think of an interface as a good example for an abstraction. And an abstraction means you don't do the details. You just work with the idea. Okay? Now, when we talk about levels of abstractions, we refer to sometimes you have, say, the data access layer usually has some notion of the database on one hand and some notion of the business domain on the other hand. While other layers in the system might have different abstraction. They might not relate to the database, or they should not relate to the database at all. They shouldn't be talking database language. You shouldn't be seeing no SQL and no stored procedures there, and no, say, entity framework code or other ORM code on the other levels of the application. Now, I'm claiming this little snippet of code is flawed in the consistency of its abstraction. Okay? Can someone suggest what I'm trying to say by that? What's inconsistent here? Inconsistent. Non-consistente. Is that right? See?
Implementation.
Out of space.
I think a Wallapop message. Wallapop message.
Okay. So now we're going to go over a few design best practices I'm sure you're all familiar with, but this is a good time to remember them. And I'll just try and explain how each of these design best practices is aimed at managing complexity. Because managing complexity is really the only thing we should be doing. Common closure. Anyone knows this one? No one?
No.
Common closure is a design practice that says that classes that change together should be packaged together. Like we said before, the way you package is less important than the fact that they should be packaged together. Which means that if you anticipate change which would affect a certain part of the system, package that part of the system in a way that you can change it safely without touching other things, which is exactly managing complexity, right? That's what you do. You want to avoid changing your whole system when the change happens in one place. You want to be able to do it. Drive principle, do not repeat yourself. Same thing. Reinventing the wheel. Once you reinvent the wheel, once you do something, I swear, one of my bosses once called me to his office and he said, I have a great idea, you won't believe, I thought of it, I slept the night and I woke up, I had an epiphany. You know the word epiphany?
Yes.
Epifanende? What's it called in Spanish?
Epifanía.
Okay, so what we're going to do, we're going to write our own tree control. And I said, no, we're not. So do not reinvent the wheel. If you reinvent the wheel, you have to deal with more. And you want always to deal with less. Okay, Yagni, anyone familiar with that? You ain't going to need it. Write what you need, don't write what you don't need. You need iceberg classes. Iceberg classes. Familiar with that? A class should have an outer. Icebergs are usually you see a small part of them above the water, but the big chunk is inside the water. And the principle is you should be writing classes that have small outside interface to interact with, and most of the class should be invisible, which means private method, private data fields, and this again plays for the same thing. If the class is less exposed outside, you can change it easily inside without having to worry about the places you use it. Yeah, this is the number one juggling problem, mental juggling problem. You're going to change something and you're not sure how it's going to affect the rest of the system. So one of the cures for that is doing many tests, having many tests. If you have many tests, you could, to a certain extent of reasonable safety, you can say, okay, I'll change what I need to change and I'll run the tests, and if the tests pass, then I'm good to go. But even better, if you can have it built in a way that you're sure that you're changing one thing and it's not going to affect your clients, you're doing a better job. Common reuse. Okay, that's the same thing we've seen before. You need to eliminate waste. We have in our code old grid. Before we started working on the new grid, we had a grid that was we wanted to freeze the state so that in case we get cold feet, we can go back to what we had before. Do you have some things like this? You clone something and you call it old something. So delete the old something, at least when the new something has proven itself solid. Solid is a bunch of principles. Okay, anyone knows, anyone can recite by heart the principles inside solid? Single responsibility is the first, right? Right? Open, close, right? Liskov. Did you know Liskov is a chick?
Yes.
You did? I didn't. Yeah, right. Intersegregation and the D. Right. Okay, so let's have a few words about each of them. Single responsibility is very simple. It says that each part of your system, it could be a class, it could be a function, should have only one responsibility, a single responsibility, not doing multiple things. The good naming will help you with that. If you give the proper name to a method or to a class, you know that it does the one thing it's named for, and not many arbitrary things. Open, closed, class.
For expansion, closed for modification.
Right. So if the class is closed for modification, you know that you have only one thing to worry about. You have less things to worry about when you need to handle the class. List of substitution principle.
the method that, sorry.
That the duck is a
an
duck.
object that is, well, if some object inherits from parent class, you should be able to replace the child by its parent, and it shouldn't affect the.
Exactly, and this is exactly it. This is just the right way of using interfaces and classes, which means that the code that consumes the interface or consumes the class does not have to be aware of the implementation details, and this is exactly what we discussed before. This is a principle that helps us manage less and have less balls in the air and have less and manage the complexity, have less things to worry about. Interface segregation, this is an interesting one. A few words for someone who might not be familiar with it. Sometimes you want to take the functionality of a class and not only hide it behind an interface, you want to hide it behind multiple interfaces, because there might be more than one customer who consumes this class, and of those customers who consume the class, some consume a part of it and some others consume some other parts of it. And you want to be in a position where you can say, okay, this consumer only needs this part, so I'll create an interface for this consumer to avoid a case when this consumer uses stuff that relates to the other consumer. And that's again the same principle that we discussed all the time. We want to be busy with less. If we use two interfaces instead of one, we are now sure that the part that does functionality A only uses the A interface of the class that does whatever it does, and it doesn't use the functionality that belongs to something else. Am I clear? Is that understandable? I have an example too. Never mind. Okay, fine. Okay, dependency inversion. Okay. Same thing we discussed at the beginning. This maybe is worth talking a few words about. A good method is a method that when you read the signature of the method, you understand very well two things. You need to understand maybe three things. Two things. Three things. Oh, depends if it's a function or a method. You need to understand what the function does. And this is supposed to be reflected on its name. Okay? And for functions, you need to know what the function returns. Okay? So this is also reflected by the name. This is part one. And the second part should be what this function needs in order to operate. Now, sometimes you might be tempted to send in the function more than the function needs. Okay? Do you know the term God class? There's an anti-pattern which happens a lot in the services world when you have an interface that is iServices, and you can just send it everywhere, and wherever it goes, it does. It has all the functionality on it, and actually, when you read the function, you don't know what it needs in order to function. If your function needs logging services because it wants to write logs, it should be receiving an iLogger. And if it needs data access, it probably should receive iData access there, or let's say that's what it needs. But if it gets iServices, you don't know if it's using the logging services or the communication services or the database services or all of them or none of them. And I've seen that too, that the function gets what it doesn't need. So these things should be very clear. And when these things are clear, you have a clear interface into the method. And this goes to classes, okay? And this goes to just anything you can think of. Try to be clear on the boundaries. If you're clear on the boundaries, you're doing a very good job. Being clear on the boundaries also means you shouldn't be using a static context. The problem with static context is that the function no longer states what it needs to operate. Because it has some assumptions that something in the global scope is initialized in a certain way. Now, this is also a thing that testing eliminates almost totally, because once you try to write a test, and you have to ask yourself, oh, just a minute, if I'm writing the test, before I invoke the function and send inside the things that are explicitly required, I also need to initialize some state in the static context. And right away you understand you're doing something wrong. Okay, so that's all nice and dandy. That's from Notes of the Brain. This is Golem. It's mine, my precious. Yeah. So how do we propagate this proper thing to our work and to our organization? This is Han Solo. I'll explain. Okay, programming is done solo. Does anyone have the fortune of working in an organization where you program in pairs? That's great. Where are you guys working?
Well, it's actually, we do it occasionally. We have this day what we
Occasionally.
call pre-Friday, and on Fridays you have spare time to invest in something that you think is valuable for the company, and usually you do that kind of practice.
That's
It's a spare
Google
programming.
thing?
Yeah, yeah.
You work for Google?
No, I work for Capside. It's called Capside. We're mainly a sysadmin company.
Sysadmin.
Yes, but we kind of develop our tools, and I happen to be the only devil guy in the house.
Hmm.
So yes, during this kind of pre-5
This
days,
is a great thing. How do you find it?
well, in
Do you
terms
learn
of
a lot from it?
in terms of the pair programming or
Yeah,
working
the pair
with.
programming.
Oh, I would say it's probably one of the days that I learned the most.
Yeah. This is very important because there's a question how to propagate knowledge in the organization. For instance, you might have an organization where some people are very experienced, or some people are very smart, or just happen to know a lot. And sometimes the management need to think, how do we propagate this knowledge? How do we get other people to get this knowledge? And if you teach someone something on the first day, they have it for the rest of their career. And if you don't teach them, they might stumble into it and they might not. So pair programming is really great for that. And also code review. Do you do code review?
Yes.
Yeah, most of you have code review in your, that's also a very good thing. Though I should be very careful not to be too shaming with that. So as programming is usually done solo, communication is required. So there needs to be a way of communicating with each other. There's something, there's somewhat of a problem in our trade. The problem is that software development, I hope it's the same in Spain. I suppose it's the same in Spain. Is a good earning. Is it the same in Spain? Yeah, it's a good. You get paid okay. Yeah. So same in Israel. And sometimes people come and program for the wrong reason. Of course, all of you who came here at this time and stayed after the break, you of course like programming and you want to be here. But some people do program for the wrong reasons. And they don't like what they're doing. So that's something you should understand, because we care for doing good stuff, but some people just don't. And this is something you should be aware of. This is from The Matrix. Yeah? And I like this scene a lot. I looked for the picture when he said, "I don't care. It feels like it. Yeah. Okay. So you have to encourage socializing with preferably with people that are in the thing. This is a joke, a local Israeli joke. So ignore the picture. But you need to discuss the process. If you see something good, talk about it. With tears if possible. Talk about readability. Talking about readability is something that is rather easy because we do get to see each other's code from time to time, even if there's no specific established way of doing it. We do get to see someone is calling you over. Look, this is that. This is not working the way I expected, and everything. So. Ask yourself is something good for readability or not. Talk about abstractions, which means try to talk the same way you split the code. So this class is that, this class is that, this module does this. So if you talk this way, it becomes part of the discussion. Usually, from my experience, over-design is usually not the problem. So if you're in a situation where someone where you're considering should you start coding or should you think a little more about how the code should be structured, try and think a little more about how the code is structured. That's my experience. Do you find it that usually the problem is coding with too much design or too less design?
Too less design.
Too less. So this is common.
No time for.
No time. Yeah, but this usually costs more because when the problems come, it's harder to fix them. So good reasoning about that goes a long way. Encourage design consultation, which means go and ask people, what do you think about this? I think I'm going to do it this way. What do you think? So next time he will come over to you and ask you what do you think, and this will create some sort of culture, and it's good. Everyone ends up smarter when you do that. This is something that is a bit debatable, but I think in most cases you should always first think of the readability of the code. Readability, if you need to trade between readability and performance, you might be mistaking, which means that you can get the performance without losing the readability. There are some extreme cases where the readability is affected by performance. My experiences, I don't have numbers to show for that, but my experience is that people are very poor in being able to predict what causes performance problems in advance and even after the process is written. So if you have ever had a performance problem with something and you approached it and you had, usually instinctively we start the process by guessing where the problem is, right? So I find it that many times, maybe most of the times, I guessed wrong. The problem is not what I thought, and it's usually something else. And you don't know it until you start benchmarking. You have to benchmark, you have to build your test cases, you have to put your timers, and you have and then or run your profilers, and then you know what the problem really is. So when you're building the code, try to build it to be maintainable. Don't do stupid shit. You could do stuff, but think of the maintainability. When the problem comes, find it and address it. That's what I said. We're not good at predicting issues. KISS, you know this principle. Keep it stupid. Keep it simple. Okay. Have expectations. When I say have expectations, I mean expect other people to do to do stuff in a good way, which means I expect the programmer to read error messages, right? Yeah, I'm telling my stuff when someone calls me and they hasn't read the error message. I say, you're not a user. You gotta read the error message. Once upon a time, the compilers used to produce error messages that were horrible. You couldn't understand what the problem was. Does anyone remember those days?
Aura 9001.
Yeah, things have changed, and now if you read the error message, you usually get a very good idea of what's wrong. So, read the error message, read and understand the warnings. There are warnings, and they are there for a reason. Does anyone work in an organization where warnings are treated as errors? You know, there's a switch. You guys are lucky. This is great. Does it make you? Does it give you a headache from time to time? How to treat stuff?
Well, it hasn't been a problem. That's right. Someone had the goodwill to fix all of the warnings that were being treated as errors, and they said from this point on, it's on your hands, and you have to be careful not to produce any more warnings.
It's a good thing. It's a very good thing. I wish I could do this. We have thousands of warnings in our code, and it's too late for that. But if I could, if I would start over, I would treat the errors as warnings. Document and read the documentation when relevant. We talked about this. Try to avoid code smells, things that are expected to be a problem. Talk about conventions. Okay. Keep a document, okay? And when the new guy comes, the first thing you should tell him, okay, you should take him around, show him everyone, this is Clary, this is David, this is the documentation, these are our guideline, please read that, and when he gets something wrong, you should, usually we see the code for newbies more often. So make sure they follow the documentation and they streamline into the conventions of your place. Discuss convention with your team. You can from time to time ask if a convention is good. If it's not good, maybe you should have another convention. The point is to make the code feel at home for yourself, for your future self, and for the people who are going to join the organization and now working on a specific piece of code, but they're going to be working on another piece of code in whatever time, and it's very important for all of them. Code reviews, if you can do. Code analysis sessions, you know, when you put some code on the board and you discuss the ways you can do it. Talk about code when you give advice, when you do something. Talk about code when you take a break. Be creative about it. Talk about your experience with the code. This is a very important point. This is a way of bringing higher quality to the work of your peers without being condescending and without saying, well, you don't know anything. Use phrases like, this made me expect that, okay? Like if you see a misnamed variable that doesn't hold what it should be holding. So just say, I was seeing that it was called first customer, so I assumed it is the first customer, but now in the loop you're changing the customer every time, so it's no longer the first customer. I expected it to be the first customer. That makes you stupid, not the code. Yeah, I was expecting it. Okay. From this I understood right away that this is a way of saying a good thing. Okay, I saw that it says first customer and I knew it was the first customer, no question. This was misleading, did not follow the standard, was too long, was too short. Just talk about it. Okay, don't address only the problem, try and talk about the code. Don't talk about code. When don't you talk about the code? When you don't understand it. What you need to do when you truly don't understand a piece of code. This happens, not to you, but to me. if you see a piece of code and you read it and you try to understand it and you don't understand it, the thing you should do is you should say to the guy who wrote this code, please go fix the code. I can't understand what's going on here. Code should be written in a way that is comprehensible. Use tooling. Measure stuff. Okay. How big are your classes? How big are your modules? Try to have a sense of what's going on in your code. Use tooling to enforce quality standards and conventions. There are build tools. Anyone here uses checking gates? Okay. There are tools that can enforce some things. Okay, so sometimes installing the tools automatically promotes the quality of the code in the whole organization because it won't take treating warnings as errors is one of the toolings, is a specific example of this, which is a bit extreme, but there are many tools. There's the minimal, I think the not checking in code that doesn't build, which also sometimes has to have some exceptions too. But use tooling. There's lots of tooling. And there are some toolings that both boost productivity and help you create better code. Anyone here using ReSharper or any tools by JetBrains? Maybe our Storm IDE. Yeah, they're good. So for those of you who do .NET, ReSharper from JetBrains. They're very good. Check their site. You might find that tool that works good for you. And it helps avoid human error. For instance, I had an example for that. Sometimes we assign a value to a variable. We think we assign a value to a variable, but we don't. A very common example of that. The constructor of the class takes a parameter and stores it in a private member. Say a service or something. You have this in your code, you probably do. Yeah, for later use by other pieces of the class, and you assign the value to itself. You assign, instead of assigning the service you just got inside, you assign the internal variable to itself, because they usually have the same name, right? Did it ever happen to you? And so tools like this can tell you you're not using this variable. You're taking it in, but you're not using it. So why is it here? And that helps you avoid such problems. Make sure everyone reads this book. This is the Holy Bible. It was written 30 years ago, I think. I don't know if it has a Spanish edition. Does it have a Spanish edition? And it still holds as new. As all the things we've discussed tonight are, nothing is new there, and it's all very, very important and very useful. Okay, just a few things. We're just about to complete our session. There's some things in our trade that are culture related, and they're good to understand too, because we've been discussing some things that are, you might consider them are absolute truths. Okay, managing complexity is definitely the way to go, and most of the things we discussed are just plain truth. There's no debate around them, and just a few things that might be debatable. But software business is not always the same as software craftsmanship. Okay, software craftsmanship follows the guides we just discussed. But software business is not the same thing. Okay, I think that generally you could generally say that things are improving in that term. Today, if maybe 20 years ago, it would be very common that developers are run by people who are not developers, because developers were young and usually all developers were hard to come by. So managers weren't understanding the principles. And now this is improving. So we see more development managers that are developers and understand the issues that we just discussed. Also, the business model has changed a bit. Is anyone here familiar with waterfall design model? Waterfall design model was the concept that ruled the industry before the 2000s, and it was about this way, roughly. The customer would come to you and they would like to have a program built for him. So you would say, okay, let's make a contract with the paper that says what you want. So now a year starts when every field in every table is written down on paper. Every control on every screen is written down on paper. Everything is drawn. And by the time you finish that, you start developing it, and the customer gets some of the program and says, wait, the guy that designed this has already left, and this is total crap. I don't know why he designed it this way. Now we have to start over. And then you would start arguing about money, because it costs a lot to make the document, and it costs a lot to develop. And things were not working very well. And today, usually, software is developed more like in partnership. So the agile systems, anyone here does agile? The agile system makes the client some sort of a partner where he has to choose the features he wants, and the development cycles are shorter, and the customer gets some more functionality on the way. So things are getting a bit easier with this. Managers understand the cost of bad code, the cost of fixing things later in the process, and they have more experience. So in that term, we're moving forward, and the industry is getting a bit better. And still, as programmers, we should remember that sometimes it's fair to treat quality the way we treat code you're not going to use. Sometimes you need to build quick and dirty for business reasons, and not apply all the clean things you do. You should always use your brain. Okay? You should always say what you think, because managers sometimes can be intimidating, and the business side of things can be a bit pushy, because they're used to pushing sometimes I have to explain my bosses that bargaining with me won't change the time that it takes to develop something. They can bargain with me, but it doesn't work. So say what you think. Stick to your estimates, because your estimates are your estimate. Accept lower quality as a legitimate business decision. It's fair. They can decide that they want, if they understand the risk, they can decide that they want lower quality. Pick your battles, don't fight over everything. Keep doing what you love, because this is what we love. Hopefully, I think all of us in the room. In acceptable conditions, we usually have that. Keep calm, and thank you very much.